One last partial fractions problem. If you'll notice, we have the integral of x squared plus 4x minus 4 over the integral of x squared plus 4x minus 5 dx. This is another circumstance where we don't have a proper fraction. The problem is the degrees of the numerator and denominator are the same. We could use long division to try to solve this, but there's another quick technique that we can use, and that's rewriting this in two integrals. The first integral, you'll want to write the numerator as exactly the same as the denominator, and you'll see why in just a minute. So we have x squared plus 4x minus 5 over x squared plus 4x minus 5 dx. In the second integral, you want to include whatever's left. Notice that this integral is x squared plus 4x minus 4, which is almost the same as what we have in the numerator up here, except we're off by a factor of 1, by plus 1. So what we're going to do to compensate for that essentially is we're going to write the second integral as 1 over x squared plus 4x minus 5 dx. Notice how the denominators are the same, so if we were to combine these two fractions, we would just need to add the numerators, and we get back to where we started from. So now we consider new integrals. This one we'll address on the left, we'll address in just a minute. This one is one we'll do by partial fractions. Our two fractions to consider are a over x plus 5 plus b over x minus 1. Just like with previous problems, we know that we need to match the numerators, so a times x minus 1 plus b times x minus 5 is equal to 1, which is the numerator of our original. Plugging in x is equal to 1, which is the factor where x minus 1 is equal to 0, we find that b has to be equal to 1/6, and plugging in x is equal to negative 5, we find that a is equal to negative 1/6. So rewriting all of this again, we have that very first integral, which was the integral of x squared plus 4x minus 5 over the integral of x squared plus 4x minus 5 dx. We have the integrals that we just found out by partial fractions, the negative 1/6 over x plus 5 dx and the 1/6 over x minus 1 dx. The really cool thing about us writing the numerator over the denominator in the first integral is that just reduces down to 1. So we just need to integrate dx, which we'll see in just a second, has its antiderivative of x. The integrals of the other parts are similar to other problems we've done with natural log, where we get negative 1/6 natural log of x plus 5 plus 1/6 natural log of x minus 1, absolute value plus c. The x plus 5 has a negative in front of it, in front of the natural log, so it will go to the bottom inside our input for the natural log, and so this is our final answer. Another trick to use when using functions of the same degree in the numerator and denominator.